Hi there. Printing with Nanoscribe with multiple resolutions. If you're a user of Nanoscribe, you know how valuable it is to be able to print with Nanoscribe with multiple resolutions and how it can make the printing process faster. So here I'm going to explain a trick that we can use to basically print with multiple resolutions with Nanoscribe. So for this example here, I'm going to explain how to print with two resolutions, but from there, if you're interested, you can print with a higher number of resolution, three, four, or even more. So first, if we go to our model here, we have this model as an example. What we have here is a grating, which I want two gratings, which I want to print with high quality and high resolution, and there are some bases which I don't care about the resolution, so I want to be able to print these as fast as I can with the low resolution, and then when the printing process get to this part, I want to print them with the high resolution. So for this model, the first thing I need to do, I need to basically export this CAD model to as a STL file so I can open them with the Describe, which is the Nanoscribe software. So first, I'm going to export this CAD file to as a STL file. And since I want to print with two resolution, I need to actually create two STL file for this method. So I'm going to uh, create the first one as high resolution, and I'm going to export another one as low resolution. Okay, so now if we go to our folder, we have two STL files, one for high resolution, one for low resolution. So we should start with one of them. So I prefer to start with low resolution, but it doesn't matter. I open the file in the Describe, which is a Nanoscribe software here, and I should put the basically in the model in the one orientation that I'm interested. It's very important that whatever I do for this orientation and the setting for this low resolution, I should have almost the same for the except the slicing and the resolution. Everything should be the same for both models. So I should keep in mind whatever I do here because I need to repeat them for high resolution. So I'm going to put the coordinate at the center of the model, and for lens, I'm going to choose 63x. So that's for the first step. And for next step, so for slicing, I'm going, since I want to print with the low resolution, I'm going to have a big slicing distance here. I should say in this script there are some feature that allow here I can choose adaptive, which allow me to change this, which allow the change of slicing based on the design. But it's not very, I don't think it's very useful. So I'm not going to use it here, and I don't think for this method we need that. So I'm going to stick with fixed and zero point 0.6 micron for the slicing distance. In next step for hatching, I'm going to have like 1 micron because I want them to be really with low resolution. So I'm going to hatch angle offset. I'm going to have it like 90. And the next step, so in next step, I should align the blocks. And it's very important here, as I said, whatever we do here, we should do this exactly the same thing for the other resolution. So one thing very important here is that one one thing that very important here is that the way that we separate between the low resolution part and high resolution part is the blocks. So here, basically, the block is the way that we're going to differentiate between low resolution part and high resolution part. So in this model, as you see, I adjust the blocks in the way that high resolution parts are separated by two blocks from the low resolution part. So in this model, what I have here is six blocks, and the first four one is going to be printed with low resolution, and the other two with high resolution. So I'm going to save this. Mm, I think, yes, I'm going to save it over here. And let's look at the model. Okay, so now you can see this printing process is 5 minutes, about 5 minutes, which is very fast. It's very good. However, you can see the resolution of the model is very low, and I don't want to print migrating with these low resolutions because they would be terrible in the quality. So in next step, we should start working on the high resolution file. So I'm going to open this time the STL file save with the high res here. And as I said, so here I should do exactly what I did for low resolution. This is very important for this method. So as I did before, I should bring the coordinate at the center of the model, and I will choose 63x again for lens. But here I can change, I can have a different slicing and different hatching because I want to print them with the high resolution. So I'm going to choose zero point 0.2, but you can go lower, a smaller slicing distance. I'm not gonna go lower than this because my computer could have problem processing it. So I'm gonna stick, for this demonstration, I'm just gonna stick with the zero point 0.2 micron. And the same for hatching, I'm going to leave it as zero point 0.2 and as I had before, so 90 degree. So one thing here, very important for the output, as I said, we should do exactly the same thing. So if you think, if you need them, you even should write them down, the parameter that you assign for one resolution, so you can copy them exactly for the next resolution. So here I have one, I think, yeah, for Z direction, the block was 150, and we have exactly the same thing. The only difference is that we printing it with high resolution. So I'm going to save that, and let's look at this model. Okay, so now we have our high resolution model here is very good. However, the problem, as you see, the time. So the printing process of this model is 1 hour and 60 minutes, which most of it would be the printing of the lower part, which I'm not interested to do this. So now what we should do, we should combine these two models that we created to basically reduce this time. Okay, so now first I'm gonna close these job files and I'm going to the folders. So here what you see, I have two job files and two data files, one for high resolution and one for low resolution. So the job file is the one that we send to Nanoscribe for printing process. So since we're going to have one printing process, I need to delete one of them. It doesn't matter, so I'm just going to delete the high resolution job, and I'm going to change the low resolution job to uh, brag rating, because so here this basically job file is for both printing both part actually. And so we see that we're going to combine data files to basically create one printing with different resolutions. So I'm going to open the job file. So as you see here in this job file, the file is basically calling for braggating low-res data file. But we also want to call for the uh, high resolution data file. So I'm going to copy this part and paste it over here, and I'm just gonna change low to high. So what's happening if I run this jar file here? What's going to happen is that the program will print this low resolution part, then it's going to print the high resolution part, and that's not what we want. We want the lower part for low resolution and higher part for high resolution. So what we need to do now, we need to manipulate the data files to based on what we need. So if I go to data file and, for example, first I'm going to open the lowest data file. So you see here we have 6 blocks that they were going to be called in the data file in the printing process. And as I mentioned before, the 4 of them are for low resolution part, and the last 2 is for high resolution part. So, but in the low res data file, I don't want to print the last 2 blocks. So what I'm going to do simply, I'm just gonna comment them. Okay. So now they are commented and they are removed from the basic data file. So I'm gonna save this file here. Now I need to go to the data file of high resolution. So in the high resolution, I actually should do exactly the opposite. So I should comment the first part, because the first part, I don't want to print the first 4 blocks. As we basic comment or remove the from code, it's very important. They should be exactly opposite of each other. So since these last 3 lines were not commented in the previous code, I comment them here. So it's very important to keep that in mind. So I'm going to save this, and now we can close the data file. So data file, there are good now. So now we have our job file ready, and we can do the printing. But let me just point out about the power in the printing. That the power in the printing should be adjusted well. If the power in the printing is too high, there will be some bubbling during the printing, and it's really going to mess with the printing. And if the power is too low, the structure would be washed away during development process. So it's important that you choose the right power. So and the power should be adjusted well with the resolution. Basically, the lower the resolution, the higher should be the power. So since the first part is low resolution, I'm going to increase the power to like a scale power scaling to 2, and the laser power to 100%. So that, but that's for the lowest part. I need to change that for the high res part, because if I print with this power for high res, I'm going to have a bubble. Definitely, I'm going to have bubble in the printing process, and I don't want that. So I need to adjust the value. So probably and to the some medium value for the power. So basically, what I'm doing here is I'm copying the power line from above below, so I adjust the power for the printing. So here we have our file ready. Our job file for the printing is ready. But before I run this job file, I just want to show you how it's like just print the lowest part. So I'm going to comment them for now, and let's look at the uh, okay. Now you see here the program is just printing the lower part because we commented the high resolution part in the data file of low res. Okay, now what I'm going to do, I'm going to bring back the high resolution and the whole thing, and I'm gonna run whole thing together. Okay, now you see here we have our printed model. So the lower part is printed with low resolution, the higher part with the high quality and high resolution. And if you look at the time of this printing process is 9 minutes. It was about 9 minutes, which is very good compared to 1 hour and 16 minutes that we had before. So this method, we easily can basically differentiate with the high resolution part and low resolution part in the printing process and have a fast printing process. I hope that was useful to you, and thank you for watching.